Hi, everyone. I'm happy to be here. My name is Elias. I'm a co-founder and CEO of zkEVM. And today I'm going to introduce you to our solution. So if you have to put some context, this is within the StarkNet ecosystem. This is within the Ethereum ecosystem. And we're essentially talking about zero-knowledge rollup, EVM, and compatibility with the EVM space, and how to bring EVM compatibility to the StarkNet ecosystem, which is an ecosystem that is built for zk, but not for EVM compatibility. So today we're going to talk about how Kakarot was born, what is our approach, and the use cases for Kakarot. So Kakarot in being like a zkEVM, the runtime and kind of the engine of the core of a blockchain. So engine of the core being the virtual machine where you can run your Solidity smart contracts and so on. So we'll look at the use cases for Kakarot for those who don't know. And yeah, so let's start with a short primer on what is the EVM, right? Like we hear about it a lot, but the EVM is essentially the Ethereum virtual machine. So it's a distributed state machine where essentially all your Ethereum smart contracts live, and where all the states of a blockchain lives. So it's kind of a CPU architecture with some additions proper to blockchain. So you can kind of see it as a computer share across the world, where you can deploy your EVM smart contracts, exchange money like cryptocurrencies, and run logic. So okay, well, so essentially what we wanted to do with Kakarot is reproduce the EVM within the Cairo VM. So you have to think there's Ethereum L1 that has an EVM. So you can write Solidity, deploy to it. And as devs, that's kind of what you do, right? You write the apps, you deploy it to the EVM, and then you run it. So this is essentially what you want. To use Solidity, build apps for your users, and kind of grow the Ethereum ecosystem. And when you arrive to StarkNet, which is a layer 2 on top of Ethereum, what you get is the promise of validity rollups is cheaper transactions, faster TPS, and essentially the promise of rollups, which is to scale Ethereum and solve the trilemma of blockchain. And one problem with StarkNet is that StarkNet is not EVM compatible. So when you come to StarkNet, you're really happy because you can have cheaper transactions, faster transactions in the future, but you are not able to reuse all your knowledge of the EVM. So for some, it's a problem. For others, it's an opportunity, but we're all about coding parallelism. So what happened? How did Kakarot actually come to life? Why didn't we just say, okay, StarkNet is using Cairo and not Solidity, so let's have everyone relearn Cairo, right? Well, Shahar Papini, the co-inventor of Cairo, wanted to try something out and kind of prove how Cairo was such a good foundation layer for the rollup space, right? Essentially, it's very simple. Cairo is a programming language, and whatever smart contract you write in Cairo, you can prove. What does it mean you can prove is you can generate zero-knowledge proofs of your transactions, and so you can batch transaction, you can batch blocks, and what you get essentially is a zero-knowledge rollup, right? And but the implications are even more powerful, because if you write an EVM in Cairo, then you have a zkEVM. So it's essentially a novel approach to zkEVM. And back in July 2022, Shah wanted to try it out. He thought, we've built the Cairo VM as a toolbox for zero-knowledge technology. So everyone writing in Cairo can have provable compute. So if we write an EVM in that language in Cairo, we will have Kakarot, right? It's kind of like an easy way to think about it is, well, Geth, the execution client, the most used Ethereum execution client, uses Golang as a programming language to write the EVM, and they implement all the opcodes, which are like the lowest level instructions that the VM can process in Golang, well, rewrite them in Cairo. So this is the only difference. And then we can prove Cairo, so we get the zkEVM. So he thought, okay, so let's write a zkEVM in Cairo in July 2022. Then in October 2022, Abdel bootstrapped a team to start working on Kakarot, and everyone joined. And the builder community of Starknet, that's so amazing, joined. And so what do we have today? What we have is 100% opcode equivalence, 8 out of 9 precompiles, almost all precompiles of the EVM, and the testnet coming, I think, by the end of August, and hopefully even sooner. So my goal is to have it by July, but if we have it in August, it's also fine. And what does it mean is that if we have a public testnet, we'll essentially have the same user experience as, I don't know, Linear, Scroll, or Polygon zkEVM. So for users, we abstract Starknet away, and what you get is compatibility with Hardhat, Foundry, MetaMask, Remix, and all the tools that you know on EVM and cherish. Then what do we have as a plan for the future? Well, we want to scale Ethereum, but we also want to scale the rollup space. So when you think about it, what we did in Kakarot is we developed a runtime for Solidity and Viper, just EVM smart contracts. So we developed the engine of a car, and now we can choose kind of which car we want. So if we want to have a ready car, we will deploy a set of smart contracts on Starknet to have a EVM compatibility on top of Starknet L2. But if we want app chains, then we take our code base, which is a EVM engine, and we put it into an app chain, and we allow people to kind of one-click deploy zkEVMs. This is very akin to, say, the recently announced ZK stack of zkSync. And in the very long future, we want to participate to the roadmap of Ethereum. So currently we are type 2.5 or 2 zkEVM, and we're going to migrate to type 1, I think within 4 years-ish, depending on the roadmap of Ethereum. But yeah, so how does really Kakarot work? I think it's non-trivial to think that right now we're making Starknet EVM compatible. So let's kind of deep dive with the flow of a transaction. So let's say Alice wants to send an EVM transaction to Kakarot. So she does it a normal way. So she opens MetaMask. She adds Kakarot to the list of networks. So in a couple of clicks, it's done. And then she sends an EVM transaction. Maybe it's going to be, I don't know, like a swap on Uniswap v2, right? So the Kakarot RPC actually is an adapter layer that's going to wrap or translate the EVM transaction to become a Starknet transaction. It's going to keep exactly the same call data. It's not going to alter the signature, otherwise everything would fail, but it's going to add new fields to the transaction just to make it Starknet compatible. Then the Kakarot RPC will call for you the Starknet JSON RPC client. So your transaction is going to be included on Starknet. And then what's going to happen is your Ethereum signature is going to be validated on Starknet. And then the Kakarot engine, so the EVM runtime, is going to fetch the EVM bytecode of your smart contract from the Starknet state and run it. So this is fun. Like, you're deploying EVM smart contracts on Starknet. They live completely as is. And then whenever you want to call them, we just fetch bytecode from it and then run it. And what's really fun is that since we're inside Starknet, we kind of leverage their infra, we leverage their prover. And so all the transactions that happen on Kakarot are proven on Ethereum L1, kind of out of the box. So if I kind of had to sum it up in one sentence, it would be that when you use Kakarot currently, so Kakarot currently is a set of smart contracts on Starknet. When you use Kakarot currently, what you're doing is you're injecting EVM transactions into Starknet block space. That's kind of what's happening. So yeah, you have to think of Starknet as a blockchain that uses the zkEVM as its engine. And then we're kind of virtualizing or emulating the EVM on top of it. A fun example is kind of if you're on Windows and you're starting a Linux virtual machine in your session, or if you're on Windows and you're starting like an emulated Game Boy or PS1, it's kind of the same thing. Because with Kakarot, all your EVM contracts just work out of the box without any change. And one thing to bear in mind is we're not doing compilation. So you're not going from Solidity, compilation step, Cairo. You're actually going Solidity, EVM bytecode, you deploy your EVM bytecode as is. So this is really EVM-like, and then you execute it, and you kind of, at the runtime, you emulate the EVM and run the transactions. So what can you do with Kakarot? You can do essentially what you would do with the EVM chain. Like you deploy your Solidity or any EVM language on Starknet, but really any Cairo chain works. So Kakarot will work on any Cairo chain without change. And then you interact with it using MetaMask, using VM, WAGMI, Hardhat, Foundry. You can do anything. Soon you'll be able also to interrupt with native Starknet protocols. And also very soon you'll be able to one-click deploy your zkEVM app chain and be part of the Starknet ecosystem. So you can think of Kakarot as many things. One way we like to put it is we're going to be the EVM actor in the Starknet ecosystem, and we're the only one right now. And I guess this is a fun part of the talk, essentially, where we debate why build a zkEVM anyways. Like, there are two types of zero-knowledge scaling in blockchain with rollups. You can build a zero-knowledge rollup based on a zero-knowledge virtual machine or a zero-knowledge EVM. So a zero-knowledge virtual machine is the example of Starknet. What you get is a blockchain that's optimized for ZK, but you break all the existing compatibility with the EVM space. So you have developers and users try out a new language. You have to build the whole infra again, and you have to lay wallets and indexer, block explorer, all of it. What you get on the plus side is better performance because you built your VM for ZK, and that's way better in and of itself. And some people told me, I don't think zkEVM is a good idea. And I think that's what they were getting at, is the EVM is fundamentally not friendly to zero-knowledge compute. For example, zkEVM is very much painful to prove. And whenever you try to kind of make the EVM fit into ZK, you're hurt and you're going to pay the price of it. So larger compute overhead and more expensive transactions. But when you think about it, the EVM is also the best thing we've had in the last year to kind of build upon. And I kind of think as innovation as an iterative process. And I used to think the network effect of EVM was overrated. Actually, it's not. All the innovation in the last years have been on top of existing innovations. And the EVM is kind of the most shared and common abstraction layer that all the devs share. So it's a good first approach for zero-knowledge scaling to expose the EVM to devs and users, but under the hood, do a lot of innovation on proving and so on. So I think this is what Kakarot aims at, and it's kind of the sweet spot of Kakarot, which is that we expose the EVM to devs so they can use Solidity, they can use MetaMask, and all of the new innovations that EVM has, we can be compatible with. But in the long run, since we are relying on the Cairo VM, every improvement that is made to the Cairo VM by Starkware, our supporter and long-term mentors, you also get. So you kind of get the best of both worlds. Of course, nothing is free, so you have to pay the price of overhead and higher gas price than just native ZK technologies. But essentially, when you use Kakarot, you're exposing yourself to the innovation of the Starknet ecosystem and the innovations of the EVM ecosystem. And I think that's very powerful, and we're very happy to be building that for the community. So yeah, I think that's really the point of the Ethereum Foundation when it comes to zkEVM, is the more the merrier. We need more zkEVMs to prove that some architectures are sound and some architectures are less sound. And I think we're going to have, I don't know, in the space like almost 10 zkEVM different designs. And at the end, 3 will survive. That's kind of my take. And Kakarot's design is very lightweight. So there are 2 designs of zkEVM. One is you take the EVM and you prove every single opcode using circuits. And you're kind of taking the EVM as a starting point and then proving it. So that's the approach of Scroll with Halo 2. That's the approach of Linea. What Kakarot is doing is actually taking zkE virtual machine, so the Cairo VM. So that's kind of our stepping stone. Everything within the Cairo VM is provable. And then on top of it, we build the EVM. So first, as zero-knowledge VM then Kakarot on top of it. And the other approach is first the EVM and then you prove it. So there are pros and cons for every approach. We think we like our odds because right now the Ethereum blockchain has not like kind of solidified. So there are new hard forks every year. And one of our best strengths is to implement a hard fork is just a day of work. It's just a couple of lines of code, because when you think about it, Kakarot does not need to write circuits. Kakarot is implemented as an abstraction over circuits. So our engineers don't even need to be cryptographers. And that's also why we built Kakarot in the span of 6 months. We're going to testnet now, and our team is literally just 7 people. So, and we used to be less. So that speaks. And yeah, we want to leverage innovations on Starknet, and we're so bullish on Starknet. I really believe that Starknet is going to be the top L2 in the coming years. And we're really bullish on using all the innovations on Starknet, account abstraction, storage proof. We're working closely with Herodotus and Pragma to kind of bring the best Oracle and best data feed that's been seen on EVM. And we're also just thinking of adding new features to the EVM without breaking compatibility. And that's going to be thanks to the whole Cairo ecosystem. So we're super bullish on it. And we're on a mission to prove L1. That's what Clément, our CTO, said. Because essentially, Kakarot is going to be eventually able to prove L1 blocks. And this is going to be right fitting into the Ethereum ecosystem roadmap. We're going to release benchmarks very soon. I think when it comes to zkEVM, someone said the devil lies in the details. So we really need benchmarks. We need benchmarks for all the EVMs. We need benchmarks for Score, for Polygon, for Kakarot, for Linear, for zkSync. And we need to be able to compare like basic transaction, gas price, speed, and we need to be able to compare so that we can all get better and kind of draw good conclusions. So I think this will be easier when everyone releases their testnet and mainnet. So I know Scroll is in testnet, Lina is in testnet, private, I think. And then Polygon and zkSync are in prod. So I think soon, in less than 6 months, everyone should release comparable benchmarks, and the space will be very much clearer. So for now, we kind of have to bear with us. You have to bear with us that research is ongoing and things change really fast. And even Polygon and zkSync, they're in prod, but they're improving every day. They're improving their zk infrastructure. Sorry, and I think that's very good. So the space is evolving very fast. So you need to kind of not do your own research, but keep up to date because things are changing very fast, and it's unclear who will be on top in terms of performance right now. But soon we should know. But yeah, so we have so much to build soon. We're going to migrate to the latest version of the Cairo smart contract language. We're going to benchmark our prover, and I think it's going to be very fun. We're going to optimize our zkEVM, and we're going to deploy to mainnet by Q1, Q2 2024. So whoever wants to try out our blockchain, please reach out to us on Twitter at Kakarot zkEVM. I'm also ETHZOU. And we're opening a Discord by the end of the week, so that's also going to be very fun. So I'll be able to share a link on our Twitter to join our Discord. But essentially, we're going to need lots of beta testers, and we're going to have so much fun. It's going to be really fun. So yeah, and Kakarot would not be possible without like kind of the help of Starkware, of many companies, and also our contributors. Because we started as kind of a community-driven project, open source, and we remain open source, open for contribution, and kind of really open to new contributors. We're going to have, for example, a rewarded bug bounty challenge in the coming month. And over the last 6 months, we kind of only relied on grants from Starknet and had more than 50 contributors, unique contributors. And only recently, the core team kind of spun off into a startup and raised funds with Starkware and other really cool people that supported us. But essentially, we're keeping our DNA, and our DNA is bottom up forever, open source, and open to new contributors. So if you want to join us, please do. And yeah, I think our testnet is going to be really groundbreaking on TPS. So I can't speak because I can't say right now because we don't know, but I suspect our TPS is going to be above the highest in zkEVM. So bear with us, and it's going to be very fun. Thank you, everyone.
Thank you, Elias. maybe you can just check out the YouTube link on the web page, like ETHShanghai.org. See, let me just check it out. Let's see if any question.
Hi.
Right now we have almost 1,000 viewers online.
That's awesome.
Yeah,
Start
looks great.
Shanghai.
Yeah. Some of the
Yeah.
people from the Korean, of course.
Can you send me
That's
the link?
good. Yeah, you can just type in ETHShanghai.org.
Okay.
Yeah.
Just one sec. Okay. Let's watch live stream. Got it.
Yes.
Okay.
Great.
Right, so I got it. Then what should I do? Can I see chat? Why don't I see the chat?
Live chat, comment. I think there's no comments inside it. Some of people are commenting in Korean. So yeah, we're all good.
All right, cool.
Thank you again. Thank you,
Thanks.
Elias, for sharing your works. I believe it's kind of I've been expecting your product much forward and your community growth. Thanks so much.
Thank you. See ya. Have a good one.
Yeah. See you. Bye-bye.